All right, today, based off of the couple of responses we had, I'm going to be doing quadratic word problems, graphing quadratics, an example of variation, and then tomorrow I will be posting some examples on triangles, sine cosine law, CAS problems, and graphing sine cosine problems. All right. So first up, we have graph the following by completing a square and find any zeros if there are any. So first, let's check if there's any zeros. So the way we can check if there are any zeros is using the discriminant. So we know that the quadratic formula says x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. But we can use the discriminant here to determine if there will be any zeros, just as like a little shortcut. So if we take, so we have, this is our a value, b value, and c value. If we take the square root of 12 squared minus 4 times 3 times 17, this will equal the square root of square root of negative 60, and you can't take the square root of a negative number, so that means there are no zeros. So this means that our function is above the x-axis somewhere. There's no intercepts. But we can still find some information about this by completing the square, and then we'll still be able to graph it. So our function is 3x squared plus 12x plus 17. So the way we complete the square is by factoring out this coefficient right here from the first two terms. So we have 3x squared plus 4x plus 17. We leave the c term outside the bracket. And then what we do is we take this b term, or not technically the b term, this term here, and we divide it by 2, and then we square it. So 4 divided by 2 squared equals 4, and now we're going to add that to the inside of the bracket. But we can't just add 4, we have to balance it out on the outside of the equation. So we have plus 17, and we don't just subtract 4 because this is we're actually adding 4 times 3, so we need to subtract 12. So now we have 3x squared plus 4x plus 4 plus 5. And now we just have to factor this in, this middle part here, and this will always be a perfect square. So it'll be x plus this term here divided by 2, and then all that will be squared plus 5. And what this means is that we have our vertex at, so we have x plus 2 equals 0, so x equals negative 2. So we have our vertex at negative 2, comma 5. And this makes sense that we have a vertex that's above the x-axis, considering that we have no zeros. So then we can sketch this and go negative 2, so we'll have it somewhere over here, and you can check like a couple points just to make it a little more accurate. So we can try at negative 1, so we have 3 negative 1 squared plus 12 times negative 1 plus 17. Negative 1 squared is, that'd be 3 minus 12 plus 17, which would equal 8. So it would be way up here somewhere, and then we can just mirror that. This is just a rough sketch. You can also use the table function on your calculator to get some more accurate coordinates. So we go to mode, table, I already forget what it was. 3, 12, 17. So we have 3, or wait, yeah, 3 alpha x squared plus 12 x. You hit that RLC button twice, and then plus 17. And we say equals, we don't want another function. And you can see at -2, 5. And then, yeah, as I calculate at -1, we have 8. Then at -3, you'd also have 8 because these quadratics are symmetric. And -2 is the vertex. So this is just a way you can check your answers if you want to, or get a couple points for your graph. But you can't completely rely on this. You still have to show your work. Alright, next up, we're going to use the quadratic formula to find the zeros for this function here. So this is already in quadratic form. If this was, say, this was like -5x squared equals 10x squared plus 7x minus 19, you'd move this over to set it equal to 0 so that you have your 15x squared plus 7x minus 19. What I'm trying to say is it's just important to have it in this quadratic form before you do the quadratic formula. So you have your a value, which is 15, b is 7, and c is -19. So x equals -b plus or minus square root of b squared minus 4ac all over 2a. So this equals -7, 7 squared minus 4 times 15 times -19 all over 2 times 15. So this gives us -7 plus or minus, let's see what that equals. Plus or minus square root of 1189. I like to leave my answers exact until I put it into my calculator for my final answer. So now we can have, we'll split this apart because we have this plus or minus here, so x equals -7. Let's do plus the square root of 1189 all over 30, which equals approximately 0.916. Just going to do 3 decimal places for these examples, and then we also have x equals -7 minus square root of 1189 all over 30, which is approximately -1.38. And then we can check our answers here. Let's pull up my virtual calculator again. This time we'll go to equation, quadratic. Our a was 15. What was our b value? 7 and then 19. -19. It equals, and then you can see our x values 0.916 and -1.38. Alright, just a way to check your answers, but it says use the quadratic formula. You still have to do the quadratic formula in order to get your marks, but it's just a good way of checking if you're right or not. Alright, I'll move this out of the way. Alright, now we have a quadratic word problem. So suppose you are a carpenter and are tasked with designing a rectangular table for a client. The table must have an area of 225 square feet. And the length should be 8 feet or more than twice its width. What should the dimensions be? So first, let's write down what we know. So the area equals 225, and the length, let's let L equal our length, equals 8 feet more than twice its width, so it would be 2W plus 8. And what dimensions would you choose for this table? So we know that the dimensions of the area of a rectangle are the length times the width. So what we're going to do is substitute into one of these equations. So we know the area is the length times the width, and then we also know that the length equals 2W plus 8, so we're going to substitute that in. So that'll give us A equals 2W plus 8 times the width. And then we also know the area is 225. So now we'll multiply this out. So that'll give us 2W squared plus 8W. And now there's a few different ways of solving this. I'm just going to set this equal to 0, because it is a quadratic, and I'm just going to use my calculator. If the question says to do it in a certain way, do it that way, but this question doesn't specify. But I based this question off of an example from your assignment where it said you're allowed to use a calculator. So we should keep that calculator open. Let's go mode. 4 for equation, 2 for quadratic, and I already forgot what it was. 2, 8, negative 2, 25. So you got x equals 8.8 and x equals negative 12.8. And sorry, and that would be our w in this case. But you can't have a negative length, so this is extraneous. Therefore, w equals 8.8. Now we can substitute this back into our equation. So let's say sub w equals 8.8 into L equals 2w plus 8. So that would mean it equals 2 times 8 plus 8 plus 8, which equals 25.6. So now we have the dimensions, so and therefore the dimensions are 8.8 feet wide by 25.6 feet long. And something we can do to check our answers. These two measurements have to equal 225, so we could just do a quick check. This isn't required, but it's not a bad idea. So does the length times width should equal 225. So 25.6 times 8.8 equals 225.3, which is pretty close. It's less than like 1% off, and that's just because we rounded at some stages. So that's how you do one of these quadratic word problems. Next up, we have a word problem here. It is one of the variation problems. So the speed of a car in kilometers per hour varies directly with the pressure on the gas pedal and inversely with the square of the angle of descent, and that's in degrees. So the first part is to define the variables and to write the equation. So say let s equal speed of the car in kilometers per hour. If you have units given, always use your units. Let's let P equal pressure on the gas pedal, and that's in newtons. And let's let D equal angle of ascent in degrees. Okay, so now we have to write our equation. So it's in terms of our speed, which is S. So S varies directly with the pressure. So the pressure is P, and inversely with the square of the angle of descent. So it's inversely with the angle of descent, but not just that, it's inversely with the square of the angle of descent. So that means our formula is S equals P over D squared. Now we have to find the constant of proportionality if the speed is, and that's K. We have to multiply our K value. Mistake there. Now we have to find the constant of proportionality if the speed is 50 kilometers an hour when the pressure on the gas is 10 newtons and the angle of descent is 15 degrees. So we sub that in. So 50 equals K times 10 over 15 squared. So 50 equals 0.4 or 0.044 repeating K. Now we just divide that out. So 50 divided by 0.044444 equals 1,125. So, and therefore, K is 1125, and the formula is S equals 1125 P over D squared. All right, that is how you solve one of these constant proportionality questions. Another part of this question might ask you to substitute in some values to find it. Once you find your constant of proportionality, like say, what is the speed if the pressure is 15 newtons and the angle is 30 degrees. So we would just substitute that in. We'd have S equals 1125 times 15 over 30 squared. And that will give us equals 18.75 kilometers per hour. And then that would be your final answer. So yeah, that wraps up this first part of the video. Feel free to go respond to that poll that I posted earlier if you'd like me to cover anything specific. And yeah, that'll be all for today.